Right, so we're looking at 28. Suppose it takes a radioactive substance 36 years to decrease by 25%, assuming there were 50 milligrams initially. So we can write out a formula. Y is equal to our A value of 50, B to the power of T, right? We don't know what B is, so we're going to have to use that when at 36 years, we're going to be decreased by 25%. So we can say 1 minus 0.25 is equal to times A over here is equal to A B to the power of 36, right? So there's an A on both sides. Those are going to go away. Left with 0.75 is equal to B to the power of 36. So to get rid of the 36 find out what B is, we're going to take both sides to the power of 1 over 36. 1 over 36. So B is going to be equal to 0.75, the power of 1 over 36. So B is approximately 0.992, right? So we're going to put our equation back in. So Y is equal to 50 times 0.992 to the power of T. Now for part B, we want to know how long it will take the same radioactive substance to decrease by 25% of its original mass. So we're going to take 0.25 times our original mass of A is equal to A times 0.992, because that B value stays the same still, and then to the power of T, right? Our A's are going to go away, so we're left with 0.25 is equal to 0.992 power of T. What we're going to do is take a natural log of both sides. So natural log of 0.25 is going to be equal to T times natural log of 0.992. So we know that T is going to be equal to natural log of 0.25 over natural log of 0.992. That's going to leave us with a T is equal to 172.6 years. Okay, looking at 29, in 2018, an initial count of turtles was taken on a small island. Population P of turtles is given by the function P of T is equal to 175 e to the power of 0.045 t, where t is the number of years since 2018. So looking at part A of 29, the second time the turtles were counted, their population was 250 turtles. How many years has passed after the initial count? So what we're going to do is set 250 equal to our P of T, so 175 e to the power of 0.045 t. First thing we're going to do is divide by 175. And this leaves us with 10 over 7 is equal to e to 0.045 t. We want to get rid of this e, so we're going to take a natural log of both sides. Left with natural log of 10 over 7 is equal to 0.045 t. Then we're going to divide both sides by 0.045 to get what our t value is. So now we know that t is equal to 7.93 years. Okay, now looking at part B, assuming the population of turtles continues to grow at the same rate, by what percentage should the population increase in a decade of 10 years? In a decade, 10 years. So what we can do is we can just look at our e to the 0.045 t. It's going to be our change. And we can do e to the 0.045 times 10. That's going to leave us with 1.5683. And then to find what our percent is, we're just going to subtract 1 and then multiply that by 100%. That's going to leave us with 56.83% increase. So looking at question 30, find a formula for a quadratic function with the zeros at x equals -2 and x equals 5 that pass through the point -1, 8. So we want to use our equation f of x is equal to a times x minus x1 times x minus x2, right? So we can say that f of x is equal to a times x minus a negative 2, and then x minus 5. Those are our two zeros, right? So f of x is equal to a times x plus 2 times x minus 5. So what we want to find is our a value to have our equation, right? So what we're going to do is plug in 8 for f of x and negative 1 in for x because of our point. So negative 1 plus 2 times negative 1 minus 5. So we're left with 8 is equal to a times 1 times negative 6, right? So that means we know that a is equal to 8 over negative 6, which simplifies down to negative 4/3. So we can say that our f of x is equal to negative 4 over 3 times x plus 2 times x minus 5. Okay, looking at number 31 here, a tennis ball is shot vertically upward from a height of 6 feet above the ground. At time 3 seconds, it was at its highest point of 177 feet above ground. So for part A, we want to find a quadratic formula for the height h is equal to f of t of the ball in feet above the ground at time t seconds after it was shot upward. We're given a hint that use the highest point and the point that represents the time 0 when the ball was 6 feet above the ground. So highest point, we can say that when it's 3 seconds, we're 177 feet, right? This represents our vertex. So what we can do is use our vertex equation, which we know is f of t is going to be equal to a of t minus h squared plus k, right? Where this is our h value and this is our k value. So looking at it now, we can write f of t is equal to a of t minus 3 squared plus k. But now we got to find our a value, right? So what we're going to have to do, according to our hint, is when 6 feet above the ground, we know our time is 0, right? So a times 0 minus 3 squared, and this was 177, so plus 177, right? So we're going to subtract 177 on both sides, 177. So we got 6 minus 177 is going to leave us with negative 171. It's going to be equal to a times negative 3 squared, right? So negative 3 squared is 9, so we're left with negative 171 is equal to 9a. So a is going to be equal to negative 171 over 9, which is has an equivalence of negative 19. So in our equation must be h is equal to negative 19 times t minus 3 squared plus 177. So now for part B, we want to know what was the height of the ball at 5 seconds, right? So we want to know what h of 5 is, right? So we're going to plug in a 5 anywhere we see a t, so negative 19 times 5 minus 3 squared plus 177. So h of 5 equal negative 19 times 2 squared plus 177. So h of 5 is equal to negative 19 times 4 plus 177. So then we have is equal to negative 19 times 4. So negative 76 plus 177. So know that our height at 5 is going to be 101 feet.
Okay, so we're looking at number 32. An apple is thrown vertically into the air. Its height, h in feet above the ground at time t in seconds, is given by this function h of t. Then part A is asking us, Find t when h of t is equal to 0. Let's do that part first. So we are going to, step 1, we're going to find t when h of t is equal to 0. Okay, so we have our function h of t. It's equal to negative 16t squared plus 48t. Okay, immediately I'm thinking, let's factor out this t. Okay, so we're going to factor out 1t, and then we're going to be left with negative 16t plus 48. Great. And so now I know through my zero product property that either t can be 0 or this function negative 16t plus 48 can be 0. So I know that t can be equal to 0, or I can set 16t plus 48 equal to 0, and then so I end up getting t is equal to 48 over 16. And so now we know we can simplify this down to 3, and so h of t is equal to 0 at t equals 0 and at t equals 3. So now it asks us, what is happening to the apple the first time h of t is equal to 0? Well, we want to think about it. This apple is being thrown up vertically into the air, and this function is showing us what's happening, right? And so at the very initial point, at 0, we're about to throw the ball into the air, and that's why it's at 0. That's why we have no height, right? And then at t equals 3, after we've thrown this apple into the air, it says the second time, that's when it's hitting the ground, right? So at t is equal to 0, our apple is being thrown. And at t is equal to 3, our apple is hitting the ground after we've thrown it. Okay, part B is asking us, at what time does it reach the maximum height? And then it's asking us, what is the maximum height that the apple reaches? So our function looks something like this, right? And it's because, remember, we're throwing this apple up into the air. And if we look at the function h of t algebraically, we can see that it is a quadratic function and it's negative, so it's opening down. So we have a vertex right about here, and we're trying to find that t value because that's going to be our maximum value, right? And so remember our vertex, to find our t value for this vertex, we know that t is equal to negative b over 2a, right? And using our function here, we can say that, we can plug in our values and say negative 48 over 2 times negative 16. And if we plug that into our calculator, it simplifies down to 1.5 seconds, right? Okay, so now that we know that our t value is 1.5 seconds, we know that it reaches the maximum height at 1.5 seconds. So that's going to be our first point, seconds, right? And so now to find the height at 1.5 seconds, all we have to do is plug that into our calculator, or into our formula and then into our calculator. So we say negative 16 times 1.5 squared plus 48 times 1.5. And if we plug that into our calculator, we are going to get 36, which that's going to be our maximum height, and our function is in feet, so 36 feet is going to be our max height. So we're going to put it over here, 36 feet. Okay, number 33. Suppose a quadratic function has the following properties. What are the domain and range of this function? Okay, so I think our first step is going to be helpful is if that we graph this, we draw it out in a graph. So let's draw this out. Right, and so it says we have a 0 at negative 2. Okay, we have a 0 at 8. Okay, so this is negative 2. This is 8. And then it says our vertex is at 3, 12.5. Okay. So this is 3, we'll say this is 12.5. So now let's draw our function. I think that's pretty good. Okay, great. So now let's look at our domain and range. So our domain, let's look at it this way, is going to be all the x values that our graph touches, right? And so if we were to like draw a line, right, and keep going down and keep going down and keep going down, right, this black function is going to touch all these points. Remember, like, if we can imagine, this goes down forever and ever and ever and ever in both directions, right? So we know that our domain is going to be all real numbers, right? Or negative infinity and to infinity, because it's going to touch all these negative infinity values way over here, and it's going to touch all these positive infinity values over here, right? Because this graph goes on forever downwards, right? And so we can say our domain is going to be negative infinity to positive infinity, right? So now we need to think about the range. So we just talked about how this function is going to go forever downwards, right? Infinitely. So we know that we're going to start at negative infinity, right, for our range. And so then we need to think about, okay, how tall does this graph go? How much of the y-axis does this graph hit? Well, we know that we have a vertex right here at 12.5. So we can say that our range, right, we know that it starts at negative infinity, but it goes all the way up to 12.5 and it stops there. But we're going to put a bracket on this because we know it hits 12.5, right? So that's going to be our domain and our range. Okay, so number 34 tells us, suppose a quadratic function of the form f of x equals a times x minus h squared plus k intersects the x-axis at exactly one time. Explain what must be true about the values of a, h, and k. Okay, well, let's think about this. If this graph only touches the value one time, it would have to look like something like this, right? Or this. So if we notice this function, ax minus h squared plus k, this is in vertex form, and we just decided that our vertex is going to have to be on the x-axis, right? And so what that means for our a, h, and k values, that means our k value has to be 0 because our vertex is sitting on the x-axis, right? And this is our y point of our vertex. So k must be equal to 0, right? What about our a and our h values? Well, the only thing this is telling us is that the graph intersects the x-axis one point, and we drew each graph, and so we said that k has to be 0. Our h and our a values could be any values, right? Those don't really matter. So our a and our h can be any, but our k value has to be 0. So a and h, any value, k equals 0.